assume that we have two tanks. We have 100-gallon tank, 200-gallon tank, and fresh water. And we are going to assume that originally this one has 12 pounds of salt in there. And then we are going to have y of 0. Initially, the second tank will be fresh water. So there's 12 pounds of salt mixed with 100 gallons of water. Here, 200 gallons of fresh water. And let's assume that 20 gallons is coming in here, and then 32 gallons are going there, whereas there's 12 gallons coming back. So there are some pumps built between the tanks so that there's constant flow of water this way and that way. All the units are gallons per minute. I didn't have space to write gallons per minute, but it's 32 gallons per minute going that way, 12 gallons going this way, and then 20 gallons going out, where we assume that all the water that, or the brine that's leaving the tank or coming in are well mixed. And I want to see what's the amount of salt at time t, minutes, and amount of salt in the second tank at time t, minutes. And additionally, so that's question one. Additionally, at what time yt is max? Right? Because we know that for the first tank, it's going to have 12 pounds, but then because it's losing it, gradually it's just going to go down, right? Because it's being mixed with the fresh water here and the fresh water here. But then, because here there's salt coming in and then leaving, there will be initially the salt here will be increasing. I don't know how much, but then eventually, because the fresh water is taking over, this too will go down to 0. So you get the idea? This one will start from 12 and then just keep going down, whereas this one will increase to some point and then it's going to come down. So let's see if this system does show that behavior. All right, so let's write down the differential equation by using this idea that rate of change is rate in minus rate out. And for here, this was fresh water, so there is no salt coming in. Now there's also mixed water coming in here, and initially y of 0 is 0, so initially it's still it's also fresh water, but at some point salt here will be going here, and then when this does have salt, this will be actually some sort of increase in the salt. So this pipe on the bottom will be providing salt into the tank 1, and the way we think about it is you have 12 out of 200. Oh, and by the way, you could also have more water leaving so that even the amount of water can change, but I made these numbers so that at each minute the amount of water is always 100 gallons here and always 200 gallons here, or else it becomes really hard to solve. So look at this one. 20 comes in, 32 goes out, but the 12 is coming out. So total of this would be just 20 going that way, right? And then 20 comes that way, so you always have 100 gallons in the first tank. Same thing here, 200 gallons, 20 is leaving, but 32 minus 12 is 20, so 20 is being provided. So this will always have 200 gallons of water. Okay? All right, so because the amount of salt in the second tank is yt, and it's 12 out of 200, that's coming into dx dt, the rate in would be this much. Okay? So you can kind of see that when we calculate these rate in, it's always the amount that's flowing divided by the amount of water in the tank, amount of salt water in the tank times the amount of salt. Okay? Because this proportion of it is leaving. Okay? Then minus. Okay, now let's think about the rate out. So the salt that's leaving is leaving through this pipe, 32, right? Now, can you come up with the rate out? What should I rate?
32 over 100.
32 over 100 times?
X of t.
X of t. Very good. All right, now let's think about dy dt. This is more involved. First of all, you need the rate in. And the only thing that's coming in is this one, right? So we should put what? 32 over 100 and xt. So what's being lost is actually gained in here. So these are actually the same. Okay, how about this one? What is that? Is that losing or gaining?
Losing.
Losing, so we put plus or minus?
Minus.
Minus, and what do you put?
12.
12 over 200. Oh, y of t, you're right. Yeah. Thank you. So you really understand what's going on. All right. But what about this one? That's also losing, so we put minus 20 over 200 yt. And the result is that we have the following system. It's x prime, y prime equals, x prime is 12 over 100. No, let's put dx dt first, the xt first. So it's negative, let's see, top and bottom are divisible by 4, so 8 over 25 x. This one also, top and bottom are divisible by 4, so it's plus 3 over 50. This one is same as this one, so it's 8 over 25 with plus. And this is 12 plus 20 is 32. And 32 over 200 is, what's 32 over 200? 32 over 200.
4 over 25. 4 over 25.
Oh, yeah.
4, 8, and 4 over 25, thank you.
That would be minus.
Oh, that would be a minus. Thank you.
Glad you could join us.
All right. So this is the differential equation we have to solve with initial condition x of 0 is equal to 12 and y of 0 equal to 0. So that can be solved. Now, what I don't like about this is that your matrix is negative 8 over 25, 3 over 50, 8 over 25, negative 4 over 25. So that's really ugly, right? And if you actually subtract lambda and do the calculations, because of all these fractions, it's not so good. Okay? So here's what I'm going to do. I'm going to pull out 1 over 50 outside. And the result would be that you end up with negative 16, 3, positive 16, and negative 8. All right. And yeah, it takes. It's if you see it, you really understand it. But I'll just say that if two matrices are constant multiples of each other, then they would have same eigenvectors, and their eigenvalues will be, if this has some eigenvalue, say 10, then this will have the eigenvalue of 10 over 50. So that's the relationship. And you can just sit down and think a little bit why that's true, but it's not that hard to see. Okay? Should I explain why? Let's see. So let's say we have A and 1 over 50 A. So what does it mean for an eigenvector? Eigenvector is if you multiply A to V, then that's some lambda times V. If there's a single number that makes this work, then we call this the eigenvalue, and this is the eigenvector, right? But if you multiply 1 over 50 both sides, then for this matrix, you have the eigenvalue of 1/50th of this eigenvalue, but with the same kind of an eigenvector. So you can translate between one or the other. And I'm just doing this because the calculation is messy. You can also just choose to plug these numbers into your calculator, and your calculator also has ways to find the eigenvectors and eigenvalues. So you can use that instead. Okay? But let's just work with this one. All right? So let's see, what's the eigenvector equation? It's negative 16 minus lambda, 3, 16, negative 8 minus lambda. Take the determinant, AD minus BC, so it's negative 16 minus lambda times negative 8 minus lambda minus 3 times 16, which is 48. And if you FOIL this out, negative 16 times negative 8 is 128. Negative 6 times negative lambda is positive 16 lambda. Negative lambda times negative 8 is plus 8 lambda. Negative lambda times negative lambda is positive lambda squared. Minus 48. And if you write lambda squared first, and then put 24 lambda, and then put 128 minus 48, that's 880, right? And if you think about it, 20 times 4 is 80, and 20 plus 4 is 24. So you can factor this as lambda plus 4, lambda minus plus 20. So that your eigenvalues are lambda equals to negative 4 and negative 20. Right? And that means this one will have the eigenvalues as, for this one, the eigenvalues will be 1/50th of what we have, which is negative 4 over 20, and negative 4 over 50. And by the way, this would be, let's see, negative 1/5. Sorry, why did I put 20? It should be 50. So this will be negative 0.08, whereas this one will be, sorry, this should be 20 over 50. So 4 over 50 and 20 over 50. And then 20 over 50 is 4.4. So those are the two eigenvalues, which we can now put here to find the eigenvectors. But I'll still use this one because they share the same eigenvectors. So let me erase this part and then continue on. So let's find the eigenvectors for each eigenvalue. So first, for lambda equals to negative 4, what do you get? You get negative 16 minus 4. I'm just plugging in negative 4 here. So minus negative 4. And then 3, 16, negative 8 minus negative 4 times AB equals to 0, 0. And that's negative 20, no, actually negative 12, A plus 3B equal to 0. Right? Negative 16 plus 4 is negative 12, and 3B equals to 0. And then you divide both sides by 3, so you get negative 4A plus B equals to 0. And since b has coefficient 1, I guess I can set a as 1. Then if you plug in 1 and solve for b, you get b equals to 4. So that gives you the eigenvector 1, 4. Okay? Now let's try to do the other case when lambda is negative 20. And negative 16 minus negative 20 is negative 16 plus 20, so it's 4. 3, 16, and then this will be positive 12. So that this time you need 4a plus 3b across down, right? So this times this, add them. And then whatever that's in front of b, you choose that to be the value of a. Then you solve for b by plugging 3 and then canceling the 3 out, you get b equals to negative 4. So we see that the eigenvector is 3, negative 4. That's pretty straightforward, right? Okay. Yeah, please tell me if I make any mistake. All right. So now we can combine the eigenvector and eigenvalue to write down the general solution. So xy is equal to c1 times eigenvector 1, 4 times e to the eigenvalue, but remember we're kind of using this one instead of this thing, right? So if we were to use this one, we will have the same eigenvector, but the eigenvalue corresponding to this one will be not negative 4, but negative 4 over 50, which is same as negative 0.08. So this one should be having negative 0.08 t as its eigenvalue, plus C2, and you put 3, negative 4, e to the negative 0.4 t. Okay. Now let's read off the top and see what they mean. X equals to C1 times e to negative 0.08 t plus 3C2 times e to the negative 0.4 t. And y equals to C1 times 4C1 times e to the negative 0.08 t minus 4C2 times e to the negative 0.4 t. And then we have to plug in the initial values. So let's now write down what happens if we set t equals to 0. If you set t equals to 0, x of 0 is what? 12. So you get 12 equals to what? E to the 0th power is 1, e to the 0th power is 1, so you get C1 plus 3C2. And then what about this second one? What would you get? Tell me. 0 equals to 4C1 4C2. Now this one's easy to solve. It immediately says that C1 has to equal to C2. Right? Just move this to the other side and divide by 4. And then if C1 is the same as C2, I can replace C2 by C1. And you get 12 equals to C1 plus 3C1. And that means if you divide both sides by 4, you get 3 as C1. And because C2 is same as C1, C2 will also be 3. Okay, so we are now able to write down the final answer. Well, not the final answer, at least for the first question we found. So the answer to that is for A, we know that x must be 3 e to the negative 0.08t plus 3 times C2 is 3, so 3 times 3 is 9 e to the negative 0.4t. Whereas y is C1 is 3, so 3 times 4 is 12 e to the negative 0.08t minus 4 times 3, again 12 e to the negative 0.4t. Okay, so that's the answer to part A. Now, second question. How would you find when you get the highest value? Right, you want to take the derivative and set that equal to 0, right? So to do part B, you want to differentiate. This comes down, so what's that? 8 times 12 is 96, so it's negative 0.96 e to the negative 0.08t. And 0.4 times 12 gives you positive, negative 4.8, right? So, but negative is positive. So positive 4.8 e to the negative 0.4t. And then you need this to equal to 0 when it hits the maximum. So what you want to do is, now you want to move this to the other side and divide, so you have 4.8 e to the negative 0.4t equals to 0.96 e to the negative 0.08t. And then you have to further solve it as, if you divide both sides by, so let's divide both sides by e to the negative 0.4t, e to the negative 0.4t. And then let's also divide both sides by 0.96. And if you use your calculator to divide this, you'll see that you get 5. 5 times 0.96 will give you 4.8. So on the left side, you get 5. Whereas on the right side, if you divide, the exponents subtract, right? The exponents subtract. And therefore, you end up with negative 0.08 minus negative 0.4, so that's same as 0.4 minus 0.08, which is e to 0.32t. And you can further solve this by taking ln to cancel with this and dividing by t. So you have t equals to 1 over 0.32 ln of 5. And I used the calculator with this, and I got something like 5 point something minutes. Okay. So I want to show you how to picture this using Python. Yeah. So this is Python, and with Python Spider, you have this nice thing called PyLab. And with PyLab, you can draw graphs just like following. So let's say let's look for the first starting minute. So we'll say t equals to a range 0 through the first starting minutes. And I'll do every 0.1 minutes I want to plot. And what I want to do is I want to plot. Let's look at it's t comma x. Let's define x first. X is what? X is can't see. 3 times exponent of negative 0.08 times t, and then minus 9 times exponent of negative 0.4 times t.
Plus.
Plus 9.
Plus 9.
Oh, it's plus. They're both plus? Okay, thank you. And then let's do the same thing for y. So for y, it's 12 and then minus 12, right?
Yep.
Or minus 4 point. Never mind.
Right? Yeah, okay. And now we plot t comma x and also t comma y. So if I plot both of them together, I have this nice looking picture here. Now, judging from the graph, which one's x and which one's y?
X is the
the
blue.
Yeah.
Blue is the x because it's just continuing to go down, whereas the orange, it reaches its maximum somewhere around 5, right? And it goes down. We can actually figure out what that value is just by doing, what was the value? It's log of 5 divided by 0.32. In Python, the regular ln is just log, and if you want log base 10, you need to put log 10. Okay? So this value gives you 5.03 seconds. So that's 5.03 seconds is about the time when it reaches the maximum. And if you want to know when it actually reaches that maximum, what the y value is, if I put it in here, 5.03. 5.03. Then you get 6.4. So you get 6.4 as the maximum amount of salt in the second tank, and it reaches its maximum. Yeah, the graph also shows about 6.4, right? It reaches its maximum when it's right after 5 minutes. So that's what we see in this